Hello, and welcome to the first in a series of lessons covering the content from Alberta's Math 10C, starting with prime factorization. We're going to take a look at our learning outcomes, review what prime and composite numbers are, then talk about prime factorizations, do some examples, then you'll have some exercises, and we'll do a summary. So, our learning outcome. Our first learning outcome in the course is to demonstrate an understanding of factors of whole numbers by determining the prime factors, greatest common factor, least common multiple, square root, and cube root. Our focus here is on prime factors. The rest will come in later lessons. So we need to know what prime and composite numbers are. Prime numbers are casually defined as being divisible only by itself and 1. I say casually. This is not quite precise enough for mathematicians. 1 is ambiguous. Is 1 prime? Is it not prime? Right? So we need something more precise than that. So a precise definition. A prime number is a number with exactly 2 factors. That means 1 is not prime. A composite number is a number with more than 2 factors. So looking at prime factorizations in detail now. The fundamental theorem of arithmetic says the prime factorization of a number is unique up to reordering. For example, 30 can be factored as 2 times 3 times 5 or 3 times 2 times 5. There's 6 different arrangements of 2, 3, and 5. But all prime factorizations of 30 have those 3 factors appearing once each in some order. That's why we say unique up to reordering. By convention, we list our factors from least to greatest with exponents instead of repeats. So if we factor 12, we'd write 2 squared times 3 rather than 2 times 2 times 3. So the general method for the prime factorization. We start with the lowest identified prime factor. We keep removing copies of it until there's no remaining factors. We move to the next lowest and keep repeating until the quotient is prime. So, some quick checks. A number that is divisible by 2 is even. That ones digit will be 0, 2, 4, 6, or 8. If it's divisible by 3, you add up the digits, and that sum will also be divisible by 3. This actually works because every power of 10, so every place value, is 1 more than a digit of 3, or a multiple of 3. 10 is 1 more than 9. 100 is 1 more than 99. If a number is divisible by 5, it'll have either a 0 or a 5 in the ones place. If a number is divisible by 7, there are tests, especially ones that preserve remainder. It's often easier just to do the division. Divisibility by 11 means alternating digits have equal sums. So in 143, 1 plus 3 equals 4. 4 is the same as 4, so those will be equal. They could also be off by multiples of 11. So 704 is divisible by 11 because 7 plus 4 is 11. But these are the main prime factors that we deal with most of the time. There's obviously divisibility rules for 4 and 6 and 8 and 9. But those aren't prime numbers. We shouldn't have to worry about divisibility by 9 because we'll have pulled out 2 copies of 3. That's what makes 9. 6 would be 2 and 3 together, and so forth. So let's look at some examples. The prime factorization of 60. All right, well, it's even, so we could pull out a 2. 30 is still even, we pull out another 2. 15 is no longer even, but 1 plus 5 is a multiple of 3. That's 6. So we could pull out a 3. The last factor left is 5, also prime. Prime factorization of 72. Again, 72 is even. We pull out a 2, leaves us with 36. We pull out another factor of 2. That gives us 2 squared times 18. 18 is still even. We pull another one out and get left with 9. So now 3 factors of 2 and a 9. 9 is a multiple of 3. In fact, it's 3 twice. When you pull out the first 3, we're left with 3. We combine that as 2 cubed times 3 squared. So here is our prime factorization of 72. Example number 3, the prime factorization of 243. Well, this one is not even, but 2 plus 4 plus 3 is 9, so it is a multiple of 3. So we pull out the 3, we're left with 81. 8 plus 1 is 9, still a multiple of 3. We pull that out, we have 27. 2 plus 7 is 9, still a multiple of 3. We pull that out. Now we're left with a 9, which we know is 3 squared. So 243 is just 3 to the power 5. That's the whole prime factorization. So these are our examples. Let's give you a chance to do some exercises of your own. First, we're going to find the prime factorization of 143. Pause now and take the time you need. All right, revealing the solution. 143, that 1 plus 3 is 4. That marks it as a multiple of 11. When we factor out 11, we're left with 13, which is also prime. Now, our prime factorization of 94. Pause now and take the time you need. Right, 94 is even. So when we pull out that factor of 2, we're left with 47. Now the prime factorization of 432. Pause now and take the time you need. All right, we add the digits to see it's a multiple of 3. It's even, it's a multiple of 2. And it turns out, as we keep pulling out 2's and 3's, that's the whole number. So 432 is 2 exponent 4 times 3 exponent 3. In summary, prime numbers have exactly 2 factors. Composite numbers have more than 2 factors. Prime factorizations, when written in ascending order of factors and using exponents for repeated factors, then become unique. So putting them in that order means we're not going to reorder the factors. All composite numbers can be factored down into a product of primes. So any number you encounter can be written as a product of primes. If it's a prime, then writing the number is the only way to do it. If it's composite, we can break it down step by step by step until it is eventually clear. It is generally easiest to start with the lowest prime factor and remove as many copies as possible before going to the next lowest prime factor. So start by pulling out the 2's, then pull out the 3's, then pull out the 5's, the 7's, the 11's, the 13's, the 17's, 19's. 23 would be next. Keep chipping away at it, and most of the numbers that we give you as in-class examples, going up to 11 is going to cover the whole thing. And it is customary to write prime factorizations in order from least to greatest factor using exponents to denote duplicate factors. All right, if you have questions or feedback, leave them in the comments and I'll try to respond quickly. I do apologize. I hear my air conditioner kicked in the last minute or so. So if you hear a background hum, that's the source. And again, I apologize for that.